All right, let's look at how we would convert a rectangular equation or a Cartesian equation into a polar equation or its polar form. And in order to do so, what we're going to do is we're going to use our conversion formulas where x is equal to r times cosine theta, y is equal to r times sine of theta, and we also have the Pythagorean conversion form, x squared plus y squared is equal to r squared. And so what we would do here right out of the gate is I would go ahead and I would exchange everything on this first problem of y equals 5x. And I would exchange the y with r sine theta and the x with r times cosine theta. So we have r times sine of theta is equal to 5 times r cosine of theta. Now, our goal is to try to remove all the y's and x's and attempt to have a problem that is only in terms of r's and thetas. And so, not every single problem is possible to write the problem as r equals or even as theta equals, but we would try our best to make that the case. And so I'm looking at this current stage here, and I'm going to divide everything by r at this point. And when I do that, I'm going to have the r's would cancel, and I'd have sine of theta is equal to 5 times cosine theta. And I'm going to turn around and say, all right, well, now let's divide both sides by cosine theta. And when I do that, the cosines cancel out on the right-hand side, and I have 5. And my left-hand side, I have an identity that sine of theta divided by cosine of theta makes tangent of theta. And we could leave it like this. All right, we have 2y minus 5x is equal to 3. And we jump right out of the gate and say, hey, we could exchange the y and the x right here for and put it in their polar form. So y is r sine theta, and the x is r times cosine of theta. Okay, and so in this step, everything doesn't have an r here, so I wouldn't try to divide by r, but instead, the left-hand side has a common factor of r, so I would factor an r out, since they both have r's. And that would give me r times 2 sine of theta minus 5 times cosine of theta is equal to 3. And here, I could get this one to be r equals if I divided both sides by 2 times sine of theta minus 5 cosine of theta. Which would give me an answer for my polar form to be r equals 3 divided by 2 sine of theta minus 5 times cosine of theta. Next one here, y squared equals 2x. And I look, and since I only have y squared, I don't have both y and x squared at the same time, it might be in our best interest to go right ahead and replace the y with r sine of theta and replace the x with r cosine of theta and go from there. So when I replace the y, I need to do it in parentheses because y is being squared. So r sine of theta squared is equal to 2 times r cosine of theta. Well, when I square r sine of theta, that's going to make r squared times sine squared of theta is equal to 2 times r cosine of theta. Now everything in our problem has an r in it, so I'm going to divide it by r on both sides to simplify it. And that's going to give me r times sine squared of theta is equal to 2 times cosine of theta. And now from here, we can get this one to be r equals if we divide both sides by sine squared of theta. And that's going to take the sine squared off the left, and I have r equals 2 times cosine of theta divided by sine squared of theta. Well, that's the same thing as having a cosine being divided by a sine, and multiplying that by another 1 over sine of theta. So I can use some trig identities and say that this problem is equivalent to 2 times cotangent of theta times cosecant of theta. So there's a polar form for that problem. So I have y minus 1 squared is equal to x plus 1. Okay, I personally would not jump into replacing the y and the x's. I would go and I would expand this first. So if I expand the left-hand side, that's going to give me y squared minus 2y plus 1 is equal to x plus 1. And you look and the plus 1s would cancel, and I could rewrite that, and my problem becomes y squared minus 2y is equal to x. Now, I would replace the y's and the x's at this point with their polar forms. And so y would be replaced with r sine of theta. And x is going to be replaced with r times cosine of theta. And then we go through the process of trying to simplify as much as we can. So we'd have r squared sine squared theta minus 2r sine of theta is equal to r cosine of theta. And everything in our problem has an r. So I'm going to divide by r everywhere. And that's going to give me r sine squared theta minus 2 sine of theta is equal to cosine of theta. Well, let's move the 2 sine of theta to the right-hand side. So r sine squared of theta is equal to cosine of theta plus 2 sine of theta. And from here, we could divide by sine squared. So that way I could get to be r equals. And when doing so, we'd have r equals cosine divided by sine squared is cotangent times cosecant of theta. And then sine over sine squared is going to leave me with 1 over sine. So I can say 2 times cosecant of theta. So there's a polar form. All right, now let's look at one where both x's and y's are squared at the same time and how we would approach that. Well, x squared plus y squared, that's a identity in itself. That makes r squared. So I got r squared is equal to 25. Now, I could go one step farther here and say, all right, well, I could take the square root of both sides, and I could write this as r is equal to 5. Now, if you were to graph r equals 5, it's going to be the same graph as r is equal to negative 5. Either one would work. Okay, let's look at this next one here. So we have the equation of the ellipse given, and we want to try to write it in its polar form. If it's me, I'm going to try to get rid of having the fractions as much as possible. And if we were to multiply both sides by 36, both the left and the right-hand sides by 36, what we would have is we would have 4 times x minus 3 squared plus 9 times y squared is equal to 36. So now it becomes a little bit easier to work with. Now, I'm seeing that I have y squared, and I have this binomial including x to being squared, so I'm going to expand it before I start plugging in any conversion formulas. And so this would make 4 times x squared minus 6x plus 9 plus 9y squared is equal to 36. Well, distribute that 4, and we have 4x squared minus 24x plus 36 plus 9y squared is equal to 36. Well, the 36's here are going to cancel out. And if I go one step farther, and, well, let's see what we have after that. We have 4x squared minus 24x plus 9y squared is equal to 0. Now, remember, I can't put the 9y squared and the 4x squared together and call that some kind of r squared because they have different coefficients. So, in fact, what I'm going to have to do here is we're going to have to go right in to replacing the x's and the y's with their conversion forms. So we would have 4 times r cosine of theta squared minus 24 r cosine of theta plus 9 times r sine of theta being squared is equal to 0. And then come through and apply the powers correctly. We'd have 4r squared cosine squared theta minus 24r cosine theta plus 9r squared sine squared theta is equal to 0. Now, since everything has an r in my problem, I have r's, r's, and r's. Here, I can divide my whole problem by r. So I'm going to divide everything by r. And so what I'm going to have here would be 4r cosine squared theta minus 24 cosine of theta plus 9r sine squared theta is equal to 0. Now I'm going to move the term that doesn't have r to the other side. So we'd have 4r cosine squared theta plus 9r sine squared theta is equal to 24 times cosine of theta. Now take out the common factor of r's, and that'll give me r times 4 cosine squared of theta plus 9 times sine squared of theta is equal to 24 cosine of theta. And then we would divide. And so we'd have r equals 24 cosine of theta being divided by 4 cosine squared theta plus 9 sine squared of theta. And we could leave it like that. Let's look at one more here. So I have y equals 1 over 2x. And if we wanted, we could go ahead and say, all right, well, I don't see anything being squared. Let's go ahead and replace the y and the x with their conversion form. So y is equal to r times sine of theta, and x is equal to r times cosine of theta. And we try to figure out how to proceed from here. Well, I would get the trig function out of the denominator. So I'm going to multiply by 2r cosine of theta on both sides. So that's going to take it off of there. And so what we have now is we have 2r squared cosine of theta times sine of theta is equal to 1. And we try to think, well, how can we proceed from here? Well, remember, multiplication is commutative. So what I'm going to do is I'm going to rearrange my terms slightly. So I have r squared times 2 sine theta cosine theta is equal to 1. Well, this 2 sine theta cosine theta should look familiar because, in fact, what it is a double angle identity for sine. So I have r squared times sine of 2 times theta is equal to 1. Well, if I would divide now both sides by sine of 2 theta, we have r squared is equal to 1 divided by sine of 2 times theta, which 1 divided by sine of 2 theta makes cosecant of 2 times theta. And from here, we could take the square root of both sides and say that we have r is equal to the square root of cosecant of 2 times theta.